These are the examples from lesson 4.4. This is example 1. Let P, -5, -7 be a point on the terminal side of an angle theta drawn in standard position. Find the values of the 6 trigonometric functions of theta. All right, let's draw a picture of this first. So we have our xy axis here, and -5, -7 is going to be down here in quadrant 3. So there's the terminal side of our angle. Now if we complete the triangle up to the x-axis, we've got our right angle here. We know this side is -5, or the measurement's really the absolute value of that. And then this side measures 7, or actually the absolute value of that. So what we're going to be missing is the radius. So we'll start off with the Pythagorean theorem, a squared plus b squared equals c squared, and figure out what the radius is. That means -5 squared plus -7 squared is going to be equal to r squared. All right. This is going to give me 74 equal to r squared. And when I square root both sides, we know that the radical and the 2 will cancel each other out. And 74 does not have a perfect square in it. So that means r is going to be the square root of 74. And we take the positive square root because the radius is always going to be a positive number. It's just x and y that change positive to negative depending on what quadrant you're in. Okay, the cosine for our angle is defined to be x over r, and our x value is -5. R we just found to be the square root of 74, and if we rationalize the denominator, we're going to be multiplying by the square root of 74 divided by the square root of 74. Okay. Hang on. This is going to give me -5 times the square root of 74, and then on the bottom, we're just going to have 74, because I'm going to get the square root of 5,476, and the square root of that is going to be 74. All right, when we get to the sine is defined to be the y-coordinate divided by r, the y-coordinate of our point, -7. Again, r we found to be the square root of 74, and if we rationalize that denominator, we're going to get -7 times the square root of 74. Again, it's going to be over the square root of 5,476, but we know the square root of that at 74. So -7 times the square root of 74 over 74, and this won't reduce. All right, the tangent of theta is going to be defined to be the y-coordinate over the x-coordinate. That means we're going to have -7 divided by -5. Well, that's just going to be +7 over 5, because the two negatives will cancel one another out. The cosecant is defined to be r over y. R we just found out to be the square root of 74. The y-coordinate we know to be -7, and that won't reduce. The secant is defined to be, r over x. R is the square root of 74. Our x-coordinate is -5, and that won't reduce. And then the cotangent for our angle is defined to be x over y. X is going to be -5. Y is -7. The two negatives will cancel, so the cotangent is +5 over 7. Example 2. Now we're going to find some reference angles. If theta is equal to 150 degrees, theta prime, the reference angle, is what? Well, if we draw the picture of this for A, and theta is in standard position, we know that straight up is 90 degrees, and straight back is going to be 180, so that means 150 is going to fall back here somewhere. So theta is 150 degrees. And right here is our theta prime. Now remember, your reference angle, that's the distance for the angle between your terminal side and the closest x-axis. And the way we find this is 180 degrees. We will just subtract off our angle theta, and that's going to give us 30 degrees. So the reference angle for 150 degrees is 30 degrees. Remember, your reference angle should always be an angle between 0 and 90, or 0 and pi over 2, depending on if you're in radians or if you're in degrees. For B, we have an angle of negative 157.5 degrees. Now that means we're going to be rotating in the clockwise direction. This is going to be negative 90. This is negative 180. So negative 157.5 is going to be somewhere in quadrant 3 over here. All right. And then the reference angle is going to go from the terminal side to the closest x-axis. That's going to be this angle right here. And the way that we can find it is we can subtract 180 minus the 157.5. And this is going to give me, let's see, that's 7, that's going to be 9, that's going to be 10. 10 minus 5 is 5. 9 minus 7 is 2. So it looks like the reference angle for 157.5 degrees is going to be 22.5 degrees. All right, for C, now you'll notice that C doesn't have a degree sign on it. That means that it's automatically in radians. And since it doesn't have a pi attached to it, it's not a giveaway angle, you know, where pi usually indicates that our angles are in radians. Okay, so in decimal form, we have 0 radians here. This is pi over 2 radians. In decimal form, it's 1.57. This is pi radians. That's going to be 3.14. Down here, this is 3 pi over 2. If we put that in decimal form, that's 4.71. And so 5 is actually going to be more than 4.71. That's going to put our angle over here in quadrant 4, which means the reference angle is going to be this one right here. And the way we're going to get this is we are going to take 2 pi, or 6.28, and we're going to subtract 5 radians from that, and that's going to give me about 1.28 radians. And so the reference angle here is going to be about 1.28. Now for D, 13 pi over 3, 13 over 3 is going to be 4 1/3 pi. And this 4 tells me that we're actually going to go fully around the circle twice. There's 2 pi, there's 4 pi, and then we're going to come up here to pi over 3. So we're going to be in quadrant 1. And our reference angle is going to be actually right here in quadrant 1. And that's going to be pi over 3. Because each quadrant 1 angle is its own reference angle. All right, example 3, we're going to evaluate the functions. We can do this with the help from the unit circle. The cosine at 5 pi over 6, this is asking us for the x-coordinate at 5 pi over 6. That's going to be this angle right here. And the cosine at this angle is going to be the negative square root of 3 over 2. All right, for part B, we have the cotangent for negative 120 degrees. Remember, this is negative 90, this is negative 180, so negative 120 is going to be somewhere in here. We're in quadrant 3. In quadrant 3, x's are negative and y's are negative. And remember, the cotangent is going to be x divided by y. So if they're both negative, that means our cotangent is going to be positive. Okay. And let's see, negative 120 degrees is the same thing as positive 240 degrees. And let's see, the x-coordinate at 240 degrees is going to be negative 1/2. And the y-coordinate is negative square root of 3 over 2. All right, I'm going to come over here where I have some room. This is going to give me negative 1/2 times negative 2 over the square root of 3. All right, and then our 2's are going to cancel, and our negatives are going to cancel. This is going to give me 1 divided by the square root of 3. And if we rationalize this denominator, we're going to multiply by the square root of 3 over the square root of 3. This is going to give me the square root of 3 over the square root of 9, and I know the square root of 9. So the square root of 3 over 3 is the cotangent for 120 degrees. All right, for 7 pi over 4, we look on the unit circle, that's going to be down here in quadrant 4. Now remember, the cosecant, this is going to be 1 over the sine, but remember the sine is just the y-coordinate there. So we got 1 over y. The y-coordinate down in quadrant 4 at 7 pi over 4, this is negative square root of 2 over 2, so we're going to have 1 over the negative square root of 2 over 2, which is the same thing as 1 times 2 over the negative square root of 2. That's going to give me 2 over the negative square root of 2, and if I rationalize the denominator, we'll multiply by the square root of 2 over the square root of 2. This is going to give me 2 times the square root of 2 over the negative square root of 4. I know the square root of 4. It's 2. So that gives me 2 times the square root of 2 over negative 2. These will cancel, and so that's just going to leave me with a negative square root of 2, or a square root of 2 over negative 1, which is going to give me a negative square root of 2. All right, example 4, we're going to evaluate the functions. And these angles are not on the unit circle, so we're going to find a coterminal angle with these angles that does fall on the unit circle. So for A, if we draw the picture, all right, this is going to give me pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi. That means this is coterminal, and it will give me the same answer as the cosecant of pi. All right, let's remember that the cosecant is 1 divided by the sine, which, remember, the sine is just the y-coordinate, so this is actually going to be 1 over y. Well, at pi, the y-coordinate is 0. This is going to give me 1 over 0. We can't divide by 0. So the cosecant at 11 pi is going to be undefined. All right, let's look at the cosine of negative 600 degrees. All right, if we find a coterminal angle for that, I can add 360 degrees. This is going to give me negative 240 degrees, still negative, so let's add 360 again. This is going to give me positive 120 degrees. Therefore, the cosine of negative 600 is going to be the same thing as the cosine of 120 degrees. And the cosine, remember, is just going to be the x-coordinate. So at 120 degrees, the x-coordinate is negative 1/2. All right, example 5. Given that the cosine of theta is negative 3 over 8 and that the sine of theta is less than 0, find the sine of theta and the tangent of theta. Okay, so what we know information-wise is that if we drew a picture, and this really helps, both of these are giving me information about what quadrant my triangle belongs in, or where my angle theta belongs. Now the cosine is negative. Remember, the cosine is x divided by r, and our r is always going to be positive. So that means that x in our case is going to be negative 3, and r is going to be the positive 8. This part right here, that the fact that the sign is less than 0, that means that the sign is negative. And the sign is negative in quadrant 2 and in quadrant 4. But the only place where both the cosine and the sine are negative is down here in quadrant 3. That means my angle is going to be down here in quadrant 3. All right, so we draw the right angle up here. We know this side measures -3, actually the absolute value of that. We just said r was going to be 8. We have no idea what y is, and we're going to need y because in order to find the sine, we want to do y divided by r, and in order to do the tangent, we want to do y divided by x. So we'll start this off as a Pythagorean theorem problem. We're going to have -3 squared plus y squared equal to 8 squared. This is going to be 9 plus y squared equal to 64. And when we subtract y from both sides, we get 55. And then when we square root both sides, now remember I'm taking the negative square root because the sign has to be negative because it's in quadrant 3. The radical and the square will cancel. Our y value is going to be the negative square root of 55 because 55 does not have a perfect square in it. All right, when we go to find the sine, remember it's y over r, so we've got negative square root 55, and r we said was 8. And then to find the tangent, y is going to be negative square root of 55. X we said was going to be -3. Oh look, and the two negatives are going to cancel out. So the tangent is going to be the positive square root of 55 over 3. All right, for example 6, we have sine of theta equal to -5 over 13. And they're telling us that our angle is going to be over here in quadrant 4. We're supposed to find the cosine and the tangent. All right, so let's get our triangle drawn. All right, the sine, remember, is y divided by r. And remember, this negative is going to have to go with the y because we want our r to be positive. That means that this side right here is going to be -5. The hypotenuse is going to be 13. And x is the one that we're going to be missing. Now, we're in quadrant 4, so x is going to be positive. That means the cosine is going to be positive. And the tangent is going to end up being negative because we have a positive x and a negative y over here. So we'll start this off using the Pythagorean theorem. We have x squared plus -5 squared equals 13 squared. X squared plus 25 is equal to 169. And if we subtract 25 from both sides, we'll get x squared equal to 144. And then we're going to square root both sides. And I want the positive square root, because remember the cosine's positive over there in quadrant 4. The radical and the square will cancel, and the square root of 144 is 12. All right, the cosine is defined to be x over r. That means the cosine of our angle theta is going to be 12 over 13. And the tangent for our angle is defined to be y over x. So the tangent for our angle is going to be -5 divided by 12.